Okay, just to set a bit of context for what this was all about, and then I'll talk to you about the sort of whole execution management story. BHP Billiton itself, we were dealing with the iron ore part of BHP Billiton, but BHP Billiton is the world's largest diversified resources company. In June 2007, they published a record result, $47.5 billion of revenue and an EBIT of $18.4 billion. They've got a project pipeline of $50 billion of declared projects, and there's other stuff that they haven't announced yet. So there's an enormous pipeline. And what's really interesting about it, there was an article in our newspapers not long ago when they announced these results, was that they turned around and said that it's a historical fact that those countries, which go from somewhere of the order of $2,000 per capita GDP per annum, have increasing requirements for iron ore until they get to $20,000 GDP per capita per annum. And in the case of China, that is expected to be around about 2050. So this is definitely not a market-constrained environment. Okay. So where we're talking about is an area of Western Australia called the Pilbara. And the Pilbara is about 41,000 people in about 500,000 square kilometers. So there's a whole lot of nothing there. Okay. Although those people who live there might disagree. Okay. And what we're going to be talking about is Port Hedland. And because the project itself is split into three different parts, and it's the mine, the rail, and the port. And it's about 400 kilometers that you go from a series of mines, in fact, that are in the Pilbara, and it goes on this rail line to the port. And that supply chain, depending on which part of the expansion is happening at what particular time, the bottleneck could be at the mines, or it could be on the rail, or it could be at the port. And what one of the ideas about this whole expansion project is that as much iron ore is what they call is direct to ship, that they don't put it into stacks and they don't reclaim it and do all the kind of stuff at the port that they would ordinarily do. So I think I've got on my next slide here. Yeah, this kind of tells you what the scale is of what these are happening. And so it went from somewhere in the order of 90 million tons per annum about 5 years ago, and then the expansions have gone up to 155 million tons per annum, and they're working on the pre-feasibility now of RGP. RGP stands for Rapid Growth Project number 5, which should take it to 200 million tons and perhaps even more than that. At the current market price of greater than $60 a ton, I can recall 2 years ago, they got a price increase of something like 70%, followed by the following year by another 20 or 25, and I think the same again happening this year. So it's boom time. They're generating more than $6 billion of revenue, and the EBIT contribution of iron ore was $2.7 billion. So it's a really good business to be in at the moment. And quite honestly, Australia at the moment is practically at full employment. And there are supply-side bottlenecks all over the place. To find people to do the work, to find companies that are there, it's really, really hard stuff to do. There are many projects that have been shelved simply because the resources are not available to do it. I think we're even employing your president today in Sydney. Okay, so just to start to paint a picture of what this complexity is about, you have BHP Billiton Iron Ore Division has contracted the EPCM, so the Engineer, Procure and Construction Manage. There's a special purpose vehicle that was developed for that called the MPD JV, which is the Mine and Port Development Joint Venture. Its only purpose in life is to expand the iron ore capacity of BHP Billiton. And that's made up of two components because BHP took the view that a company called SKM had very good engineering capabilities and Fluor had very good project management capabilities, and sort of knocked their heads together and said, you know, you blokes have got to work together. And in the first couple of years, it was a bit kind of, is it us or is it them? But it has solidified into a unit all of its own that does very good work in terms of the requirements of BHP Billiton. So that was the first layer of complexity. In the port, what you can see is a satellite photo there, which shows the two different sides. There's Port Hedland, there's Nelson Point and there's Finucane Island. And you're talking there something like 500 ships loaded each year. they can carry up to 220,000 tons of ore, and it takes something like 36 hours to load a ship. From the operations point of view, it's quite interesting when you talk about tides and whether the ship can or can't make the tide and all of these kinds of things. Right, what was the project environment? So BHP have got a fairly well-defined stage gate process. They call it a toll gating process is what they call it. And typically it'll go through a pre-feasibility, a feasibility, design, procure, fabricate, construct, and commission. And inside of all of that sits, and at each stage, you've got teams that are made up of civil, structural, mechanical, electrical, and controls. So you've got typically the civil, structural, mechanical work together, and then electrical is a separate reporting group, and controls is another reporting group. And so it becomes quite complex when you then turn around and look at this multi-project environment, because each one of those project phases can be running at a different point, and you've got all of these different disciplines of the civil, mechanical, structural, electrical, and controls in each one of those phases for each one of the stages that they're doing. So, and then if you add on to that, on top of it, that you've got the complexity now that you've got the port has got to be synchronized with rail, it's got to be synchronized with the mine, it all gets to be a little bit conflicted, should we say. Okay? So, let you have a quick read of the execution management. Okay. For those who can't read at the back, it says, tell him we haven't got time for any of his bright ideas, we've got a battle on our hands. And that's really kind of the reception that one would get in the first instance when you go and speak to people, like we're kind of really busy, we haven't got time for any of these bright ideas, okay? But it was generally accepted, and we've been doing it since 2005. And we started off in the controls section, which is really at the end of the whole project. It's right, once everything's built and it's electrified and everything else, the controls dictates or allows you to determine where the ore gets sent to and from and which conveyor system it goes on and so on. And that was really a software project. So it was considered to be reasonably easy because there was no complication of procurement that was in there. It then progressed into electrical, which added the dimension then of procurement, but that was substantially easier than the civil, structural, mechanical piece. And that's the piece that I'm going to be talking to, which also looked at the shop detailing. Now, the specific part of this project that I'm going to talk about, in which we're going to give you the results, is this thing called a car dumper, which is just as its name implies, you have what they call a rake of 100 wagons which come into the car dumper. There are 4 car dumpers at Port Hedland. Some of them have got is what they call a 2-cell, so it'll take 2 cars at a time. The one that we were working on had 3 cells on it, and literally the rake moves across by those 3. It gets registered, tips the ore out onto a conveyor, tips it back and moves it across. And it was the engineering work that was associated with that and some of the conveyors that were also involved with that. So just about what was the challenge that was involved here. The feasibility study was to plus minus 15%, but it was a brownfields environment, and it was an operating environment. So there was a tension as well, not only because you had the joint venture EPCM and you had construction companies and contractors and everything, but clearly the operations people said you can do anything you like as long as you don't take any of my capacity away while you're doing it, okay, which would be nice. The detail of the existing concrete vault remained uncertain. This concrete vault is possibly half the size of this hall, and it goes down about 5 stories. And so it's quite large and very, very thick concrete that they had to cut through and modify and do all manner of things with. The full engineering was about 25,800 man-hours of this multidisciplinary work. 1/3 of them were new staff, so there was not a lot of new learning to be done there. Engineering had to provide, there were some long lead time items which had to be provided, so that had to be dealt with. And as I've mentioned already, the BHP Billiton operations had to keep going for as long as they possibly could, because an hour lost in any one of these things is tons of ore not going onto ships. What was the approach? the whole thing was really geared and underpinned around the timely production of the engineering work. What had happened before, and this was the sort of big behavioral change that occurred, was that based on the seniority of the engineers, what happened was that they would prefer to do their work in the order that they would prefer to do it. And so, yeah, exactly. And what that implied was, and historically what the experience was, is that the drawing officers that were producing the shop detailed drawings for the fabrication were flooded and then starved, and then flooded and then starved. And then when the suggestion came along that perhaps they should subordinate and make smooth work flow through because the bottleneck really was the shop detailing, this wasn't a readily accepted idea in the first instance. You know, one doesn't subordinate to a drafting office if you're a senior engineer. But they came around and they saw what the benefit was and were very cooperative in the end. It was broken down into 25 concerto projects, and their own established engineering process was used based on engineering deliverables being what the basic size of the project was. So everything was broken down into an engineering deliverable, which actually mapped to specific items that were delivered to site. Client reviews were modeled, and there was some very interesting discussion and conversation both in yesterday's workshop and today about the sort of management overhead part not being modeled and somehow or another having to cope with that and deal with that. And so in certain instances here it was explicitly put in because it could get bogged down in approvals and all of that kind of thing. And certain milestones were added in order to get the delivery of early information. Certain stuff was seen as being critical milestones to get everything delivered on time. And I think an interesting part of the context as well is that initially, in the first part of the feasibility way back, the idea was that the car dumper would come at the end of this RGP4 phase of the project. But then, because the mine was going to come on with production earlier, it meant that any delay that was caused or any lateness or starting later of the car dumper meant that it would be less ore on ships was what was going to happen, that you couldn't ship everything that you were mining. And so that meant that there was a lot of effort had to be put in to looking at the planning side of things to say, well, can it fit within the time window that was required? And it got right down to the wire where we actually had to start thinking about, okay, we can't have all of the fabricated stuff delivered to site on time for the start of the shut, but we can have what's required first. So the sequencing of what was delivered to site was very important to figure all of that out, to make sure, and that also had the implication that the engineering had to be done in that sequence so that it was all delivered to site, because it was a very, very tight time frame that all had to be delivered. Okay, what were the results? The results were that the complete engineering works were finished 3 weeks ahead of schedule. That's unprecedented in that place. And furthermore, sort of anecdotally, when you visited the site, because all the engineering works happened in Perth, and this is I think it's about 800 kilometers. It's a 2-hour flight to get from Perth to Port Hedland. All of the stuff had arrived and was ready at site in an orderly manner. And when you spoke to people at site, they said this was very, very unusual. They were usually scrambling for bits and pieces and all sorts of things to make stuff happen. Only one package out of the original 25 was delivered late to the shop detailers, which is really something quite astounding. And it was a steady flow of work that was managed through the shop detailers, and I think that was probably the key to the success. And this was an interesting number. The productivity factor, the actual hours divided by the planned hours, was actually 1.33. So that meant that the planned hours was 25,800, and the actual hours was 19,500. So there was a saving of that number of engineering hours that it did far less than they ordinarily would have. And from what we understand, again anecdotally, that a more typical result in the productivity factor is 0.8. So that meant that it was somewhere of the order of magnitude of a 50% improvement in the productivity of the people that were working on that project, which is quite staggering in its own right. But nothing, absolutely nothing compared to why was execution management important. And that number, to me, I've been around this kind of stuff quite a while, and I've never seen a number as big as that. Because the car dumper, that's one car dumper of 4 that's at the port, and the car dumper is designed to handle 10,000 tons of ore per hour. And if you look at the throughput of $50 a ton, it's arguable whether but it's somewhere in the order of $50 a ton, then you're talking about that the potential for loss of throughput per hour if the dumper is delivered late could be $500,000 an hour. That's a big number. Okay? In an unconstrained market where you can sell every ton that you make, that's a very big number. Okay? Sanjeev reckons we undercharged on Concerta. I forget they're watching. Okay. So the qualitative improvements in execution management, okay? This was what they had to say about the whole piece. Concerta kept all the work scope in balance, and it kept it to a factual level as well. It meant that when there was a discussion, at least it could be a reasoned discussion based on a fact base that everybody was sharing. It was flexible in coping with the day-to-day change from the issues, the sort of shock absorber idea that, and understanding the difference between common cause and special cause variants. This keeping of the task up in lights was very, very important. I mean, initially it started off that the buffer management meeting was happening daily, and then it went to about every 2 days, and then perhaps three times a week or as required. But what it meant is that it kept the heat on, and it meant that people had to do the things in the sequence that they had to do them in order to make sure that the flow was continuing to go. What were the challenges in terms of the execution? Resetting a project partway through. It was always a kind of delicate thing to decide, well, do we reset it? Is it something, again, as I've mentioned, is it a special cause, so we should reset it? Or is it something that we need to work through in order to be able to, and just let the buffer take care of what the common cause variance is? Planning of inputs and outputs to the engineering work took some time to establish. We've done a number of Concerta implementations in Australia, and it's always been the case that when you're doing the critical chain planning, you never get it right the first time. It's always a learning exercise. And so how the approach works for the specific context, and also how they want to work and what their methods are, needs to be adapted. And so you need to understand that you're going to replan. This thing about management of the drawing reviews and the document checks and allocation of times and resources, these had to be formulated by trial. So it was an issue about modeling, and it was very similar in a way that I can remember when I was studying engineering, that it was always the case that it was, don't forget, guys, this is a model. This is not what reality is, you know. And so to find that kind of golden mean between too much detail and too little detail, so that you're exposing just the right amount to be able to support the decision making. And that is, I believe, a learning process. I don't think that you can go into any specific context and say, oh, this is what it is. I think that that's something that you learn as you do it. What was the buy-in challenges for execution management? The discovery process of the real meaning of buffer consumption. You know, when there's this trade-off where you say, don't worry, guys, it's a 50% confidence estimate. You're going to be over time half of the time. Oh, cool. You know, and then you come and you say, but when you're the penetrating task, the entire program's going to be watching. You know, it's like, I'm in the red. Okay. This other idea about that my activity is going red when I haven't worked on it yet. Yeah, you know that one too. Okay. And then, this is always the interesting one, is sort of gaming the system afterwards. You know, so now these are smart guys, these engineers. You know, now they've figured it out. You know, so you've got to try and sort of keep people honest about these things. But those were things that could relatively easily be coped with. What are the sustainment challenges in there? I think that there are several, and they're in no particular order. But in this industry, in sort of large infrastructure projects, Primavera is the industry default, okay? And that is used extensively. And in the early phases, when we were running with the controls and the electrical, there were already established schedules which had milestones, very milestone driven. And it was difficult, if not impossible sometimes, to turn around and say, well, it just won't fit, or the logic of how you're putting that work together just won't fit. So you now have to go and make some sort of a compromise. It was much better when we were doing the civil mechanical structural, because really at level 1 of the work breakdown structure, so the overall planning was done by Primavera, but we had a lot more leeway in terms of what we had to fit in with and the logic of how that was put together than we did the first time round. A critical thing about moving away from this earned value mentality, and it's kind of the way that I describe it, particularly when you're in a schedule critical environment such as this one, is that earned value is a fantastic tool for measuring cost, right? But using it to measure schedule is like using a thermometer to measure pressure, okay? It's the wrong instrument, okay? So, but I think that's a battle still to be won, but I think that we're making headway. And generally speaking, I think that we're making headway in that direction. And then the structure of the contract arrangements is also something that is quite critical in terms of what is the behavior that is being driven. So, is it a fixed lump sum? And that drives a particular behavior. A schedule of rates, where you might turn around and say, for the contractor who's actually doing the construction, essentially it's done on the tons of steel that you've erected. So that will drive a behavior towards saying, oh, well, there's a beautiful, huge piece that's megatons worth of steel, but you know that you need this piece done first in the sequence in order to make it all happen. And so you've got a disconnect there between that. Or a time and materials, and sort of who's watching who. And you can have a number of parties that are on different types of contract, and therefore it's very difficult to sustain something which is in the interests of everybody. And we had conversations around saying, could there not be some sort of an incentive that turned around and said, make the success based on the shortening of the schedule that everybody shares in to some extent. But that itself is quite difficult because scope changes as it goes along. And therefore, how do you manage that into an overall bonus if BHP says, well, operational reasons we've changed our minds. So really, those are the sorts of things that I think in the next phases that we're going to be dealing with.